In this video, we are going to do a second problem involving solving systems of equations using substitution. We'll compare it to elimination as well. But on the last one, substitution works fantastic if you have a variable that's already isolated. Okay, if it does, then we take whatever that variable equals and we substitute it into the other equation, which then just gives us one variable that we can solve. Then we kind of finish it up by plugging back in one of the equations to get the other part of the answer. Okay, so we're going to do a second equation. And so here's our second equation, second system of equations. The way this is set up, I really think elimination, kind of the addition method, just the way that the 2x minus the 3y equals negative 14 and the x plus 5y equals 19. So hopefully you're not forced to use a certain method. It doesn't really matter. I kind of look at this and I think this is way more set up for elimination than it is substitution. But I'm going to practice both just to kind of show you how this one's not bad actually to use substitution. There is a time that I wouldn't do it at all. So I'm looking at all four variables that we have here. And that one in particular is very straightforward to get by itself. All we have to do is just bump the 5y over. If we are going to try to get this x by itself, we'll have to divide by 2. And dividing by 2 would mean everything is going to get divided by 2. 2 doesn't go into 3 without making it a fraction. Same thing as if we try to get this y by itself, we'd have to divide by negative 3, which 3 is not going to go into the 2 or the 14, creating a fraction. So, and dividing by 5 is going to create a fraction as well. So that x is not bad. I just wouldn't have thought to use it just because of the way that everything was already lined up. So we'll do both. And so if you wanted to use substitution, totally. Let's take that 5y and let's bump it over to the other side. So then that's going to be x is going to equal a negative 5y plus 19. And our equation is, the other equation is 2x minus 3y equals negative 14. So if we know that x equals negative 5y plus 19, that means this x also equals negative 5y plus 19. So we'll sub out the x with a negative 5y plus 19. And minus 3y equals negative 14. All right, so we've subbed it out. We're not going to have anything but y's left in this equation, so we can figure out what the y equals. So we'll do distribution, right? So we'll have a negative 10y. 2 times 19 is 38. And then we'll drop down the rest. Okay, so we have some like terms to put together. I'm going to put together these y's that are on the same side, and then eventually I'm going to have to bump 38 over to combine with 14 because those are also like terms. So right now I'll just focus on putting these two together, which will make a negative 13y plus a 38 equals negative 14. We're going to bump the 38 over the other side by subtracting. So we'll have a negative 13y equals negative 52. And then we don't have any more like terms, so now I'm ready to divide, to isolate the y. So y is going to equal 4. Negative divided by negative is a positive. 52 divided by 13 is 4. Okay, so now once we have a y value, this kind of goes back to normal. I'm going to take that y value and plug it into any of these equations, including this one. So I'm going to say that x is going to equal negative 5 times our y value that we just found to be 4. We can figure out what x is if we know what y is. So that x is going to equal negative 20 plus 19. X is going to equal negative 1. So without graphing, where would these two lines cross? They would cross at negative 1, 4. Okay, and then I would do a quick check to make sure it worked. We used this equation to kind of finish it off. So I want to double check that when I plug in a negative 1 into this and a 4 into this, it actually does make the negative 14. So 2 times negative 1 is negative 2. And then a negative 3 and 4 make negative 12. It does that, in fact, make negative 14. Yes. So that tells me that this is right and we didn't just get lucky. Okay, so that was substitution. And substitution was okay, not a bad way, just because we had a variable that was very easy to get by itself without creating any kind of fractions. But like I said at the beginning, wouldn't have thought of substitution just the way it was set up. I would have thought of elimination / addition, it's the same method, two different names. I would have looked at this and said, well, maybe I can cancel my x's. So let me see how this route would go. I can cancel my x's by distributing a negative 2 into it. So there's 2x minus 3y equals negative 14. So we didn't do anything to the top equation. We're going to distribute a negative 2 into the bottom equation. So negative 2x and then minus 10y equals a negative 38. X's go away like they were supposed to. And then we combine our y's and get a negative 13y. And this makes a negative 52. That should look familiar because it's literally exactly the same step that we got with substitution. There's definitely got to be some stuff that kind of match up because you're going to get the same answer in the end. So don't be surprised if you did have to do it 2 different methods, but you got some similar pieces along the way. So we divide by negative 13. So y would equal our 4. And then once we know our y, I would not have converted it into this, so I would probably pick the bottom equation to plug the 4 in. So I would be sitting with x plus 5 times my y value of 4 equals 19. So x plus 20 equals 19, subtract 20 over to get x by itself, and x equals negative 1. So we get the exact same answer, just 2 different approaches, and you have to figure out which one you like. In theory, it doesn't matter. I would imagine most people probably prefer the elimination method, addition method, versus substitution. However, if this equation was set up like this right from the get-go, I probably would not have hesitated at all just using substitution. So, all right, that was substitution with a little bit of elimination kind of mixed in to just kind of check things and compare the 2 different methods and see which one you like.